In Unit 4, we're going to start looking at graphing quadratic functions. So we want you to be able to know what a quadratic function is and what it looks like, how to graph it. The learning targets then are to graph quadratic function using the y-intercept, the vertex, and the axis of symmetry. We also want you to be able to find and interpret the max and min values of a quadratic function in real-world type situations. Okay, so the first problem on your sheet says a rock music managers handles publicity and other business issues for the artists they manage. One group's manager has found that based on past concerts, the predicted income for a performance is given by this function, where X is the price per ticket in dollars. What happens to the income as the ticket price rises? Well, you can see from the graph over here, here's the ticket price down here. Here's the income. Initially, as you raise ticket prices, okay, you see an increase in the income. But at some point, when the ticket price gets too high, then actually less people buy it because they probably don't want to spend more money, and the income actually starts going back down. So in this one, we would say it increases until ticket prices reach, if we look at the graph over there, we can see here's where it gets to the top. Looks like at $40, that's where it reaches the top. We call that point a maximum. Okay, this point on a quadratic, which we also, this shape here is called a parabola, which we'll talk about. This location, kind of the highest or lowest point, is called the vertex. And we'll look at how you can find that. After this, then it decreases. So it increases until the price reaches $40, and then it decreases after that. This U shape or arc shape that you see here is a parabola, and you get it by graphing a quadratic function. Okay, so quadratic function. When you graph anything in this form up here of ax squared plus bx plus c, where a can't be 0, you get a parabola. Some things we're going to look at. Where is the y-intercept in that equation? Okay, and the y-intercept is always going to be your c value. Whatever c is, that's your y-intercept. Your vertex, okay, is that lowest point, or as we saw in the last one, the highest point, is found by using this formula right here. So the vertex is found by doing negative b over the quantity 2 times a, where b and a are these numbers in the quadratic function. That also tells you your axis of symmetry. Symmetry means the same on both sides. You can see that this parabola is symmetrical on either side of this imaginary red line here. So whatever this point is equally distant away from that axis of symmetry. So parabolas are symmetrical. So we're going to use all that knowledge to do some graphing here. There's two types of parabolas you can get. One type of parabola opens up, like this first one here, and it's kind of U-shaped. The other one opens down, it's kind of arch-shaped. You can tell what type of parabola you're going to have by the a value. Okay, so if we look at this a value right here, if that number a is positive, you're going to get one that looks like this. And your vertex is going to be a minimum. If your a value is negative, you're going to get one that opens down, and because it opens down, your vertex is the highest point. We call that a maximum value. All right, so let's look at this one. We want to graph this out. So in this problem, we want to know what's our a, b, and c values. The a value is always the one in front of the x squared. Here it's 1. Okay, our b value is the one in front of the x. And if it's minus like this, then our b value is, we say, is -6. So we want to take that, if there's a minus sign, count that with the number as a negative. And our c value is 3. Well, whatever that last single number is, that's always the place where your graph's going to cross the y-axis. So we know on this graph, our y-intercept is going to be 3. Okay, something else we should know right here, our a value is positive. Whenever it's positive, we should get a graph that is U-shaped. So when we're done graphing, we want to check to make sure our graph looks like that. And we should have a minimum value here, because anytime it's U-shaped, you're going to have a minimum. Okay. All right. So to find where that vertex is, that lowest point, and axis of symmetry is going to be the same thing, we use this little equation, x equals -b over 2a. So what we're going to do now is substitute in those values of 1 and -6 and see what we get. So if we put those in, we got negative, or opposite of -6, all over 2 times 1. Okay, simplifying that, the 2 negatives on top are going to turn out positive. 2 times 1 is 2, which looks like we get 3. That means the axis of symmetry here is at x equals 3. There's an imaginary line going through 3. Here's 3 on the x-axis. There's an imaginary line right here. And that, our parabola, when we're all done, should be symmetrical about that point. For example, right now we know there's a point right here at 3 that our graph goes through. That is 3 spaces away from this line. So if we go 3 spaces on the other side, there should be another point right there that our graph goes through, because that point is symmetrical. Okay, it also tells us this 3 right here, that our vertex is somewhere on this dotted red line. So the x value of our vertex should be somewhere located on this line. And since we know it opens up, it should be somewhere on the lower part of this graph, below the 2 points we already have. To figure out what that is, we're going to take the value of 3 that we have right now, and we're going to substitute that back in now for the function. So we're going to take this 3 value we have and substitute it back in. If we do that, we should end up with the y value. So what we want to find is, what is this function at 3? What if we get if we plug 3 in? Well, 3 squared is 9. 6 times 3 is 18. 9 minus 18 is -9. If we add 3 to that, we get -6. So that tells us the location of the vertex is at 3, -6. Right there. So this now is what our parabola should look like. If we connect these, we get that U-shape that we had talked about before. And that's what this parabola looks like. Okay. All right. Let's try another one here. So on the back of your note sheet is another one. We're going to graph this one now. Okay. So y-intercept. Again, that all these things over here depend on your a, b, and c. Here, a is going to be 4. B is -8. C is 2. Our y-intercept is always our c value of 2. So we know right there our graph should pass through that line. Vertex axis of symmetry use the same thing here. It uses that x equals -b over 2a. Why don't you pause the video, see what you get for that value. All right, let's see what you have here. If we plug in those values, our b here is -8. So we're going to get opposite of -8 all over 2 times 4. That's going to be 8 on top, and also 8 on bottom. Looks like you get 1. So over here, we know axis of symmetry is at 1. We also know our vertex is going to be 1 something, because our vertex is always on our axis of symmetry. Our axis of symmetry should be right there. So we already know another point symmetrical to that, the one we already got, should be right there. How do we find that other point? Okay, remember that's where you plug it back in. So see if you can find the y value of the vertex now by substituting it back in. What does f at 1 equal? Pause the video and see what you get. All right, if you plugged it in correctly here and did it right, you should have gotten -2. Be careful on this part. Remember, we should not times these together and then square. That's not following order of operations. Order of operations, our little PEMDAS saying, says do parentheses, which we already did. Exponents come next. You got to do this part first and square 1. 1 squared is 1. 1 times 4 is 4. 8 times 1 is 8. If you solve that out, you should have gotten -2. So that's the y value. So 1, -2 is right there. And it should be on our red line. This one now looks like it should be opening up. And we get a parabola that looks like that. And if we look, is our a value positive? Yep. If it's positive, that means it's opening up. Now there's another way you can do this too. You can use calculator to help you graph as well. To do that, on your graph here, or on your calculator, hit your y equals button. If you have a TI Inspire, go to your menu and select graph. And you want to type in this equation, this function, exactly how it is here. So type in 4x, hit your squared button, minus 8x plus 2. Once you have that in there, you can hit graph, and it should give you a picture of what the graph looks like. Okay, looks like, yep, our parabola that we have is pretty similar to the one shown here. But an even nicer feature is you can go to the table. Okay, and a table will give you all the values of where this should be. We kind of freehanded a little bit, but here this table tells you exactly a bunch of points that should be on our graph. Okay, so notice, one thing you should notice here, see how the points are symmetrical? 34, 34, 14, 14, 2, 2. Here's the one point that doesn't have anything symmetrical to it, because that is our vertex right here. Okay, so a table allows you to get some other values. So our graph should be going through the point right above that, 0, 2, and also 2, 2 should be points on here. So 0, 2, 2, 2, yep, we had both of those. If we look at some other points here, -1, 14 is a point. So up here somewhere should have been another point. Same thing over on the other side. So our graph was pretty accurate right there. Even if you don't have a graphing calculator, you can always make your own table and just plug in numbers. So like if you know the vertex was at 1, 2 here, 1, -2 here, probably put that in the middle of your table, pick a couple numbers bigger, couple numbers smaller, and then you can do the same thing we did right here and just plug in those numbers and see what you get. For example, if you plugged 0 in here, that's an easy one to calculate. 0 squared is 0, 0 times 4 is 0, 8 times 0 is 0, plus 2. 0 minus 0 plus 2 is 2. There should be a point at 0, 2. You should get the same thing right here because it's always symmetrical. So that's another way you can always make your own table or use your calculator to help you get the table. All right, a couple word problems now. Number 3, an object is fired straight up from the top of a 200-foot tower at a velocity of 80 feet per second. The height, h of t, of the object t seconds after firing is given by the equation or the function shown. Find the maximum height reached by the object and the time the height is reached. Some of you who are in physics probably recognize equations like this. The 80 that they talked about right away, that's this 80. The 200, hey. So the 80 feet per second, that's the velocity here of 80. Also, they told you it's a 200-foot tower. That's the 200 in that equation. Also, this -16, for those of you who might keep going, that has to do with gravity. That's the force of gravity pushing that down. So, irregardless of all that stuff, they told you we got this equation here, and we want to use it now to find the maximum height. Well, we know something. If this is being thrown up and it's going to come back down, eventually hit the ground here, that shape is a parabola. we're interested in finding the maximum height. Well, we know that maximum is located at the vertex. You find the vertex here the same way we just did on the previous two problems, and you do that with this formula. So we want to do the same thing. What is negative b over 2a? Well, the only difference here is instead of x, our function doesn't have x, it has t as its input value. So it's not x we're finding this time, it's actually the time we're going to be finding here. So plug in the same thing. On this problem, our a is negative 16, our b is 80, our c is 200. Okay, so if we put these numbers in, we got negative 80 over 2 times negative 16. I should be able to solve that. That'd be negative 80. If we multiply the bottom, that's negative 32. And if we divide that, we're going to get 2.5. 2.5 seconds. It takes 2.5 seconds for this thing, after being launched, to get to this point. But we haven't answered the question yet. That question said, find that maximum height. What is the height it gets to? Well, if we know the time it takes to get there, now we should be able to find the height, because this function up here tells us the height is this. So now you got to take this number, just like we did on the previous problems, plug it in for t, and find out what are you going to get. So now it's just a substitution problem and see what's that going to equal. So we want to find what's h at 2.5. So anywhere in this equation there's an x or a t, plug in 2.5 and see what you get. Now I'm running out of space here, so I'm going to erase this. So now plugging that in, and this is something you could do on the calculator too. Figure out what that equals and see what you get. But recall, remember, you need to, if you're not using the calculator, type that whole thing in. Make sure you do this squared first before you multiply by negative 16. Otherwise, it's not going to come out. But this would be a good one to use calculator on. Let's just type that in. See what we get here. So on this one, you got negative 16 times 2.5 squared plus 80 times 2.5 plus 200. It looks like the maximum height it gets to is 300 feet. And that would be the answer to the problem. So maximum and minimum points, use the vertex equation. All right, number 4. Libby throws a ball in the air with a velocity of 64 feet per second. She releases the ball 5 feet above the ground. The height of the ball above the ground t seconds is modeled by this equation, where VO is the initial velocity and H of O is the height at which the ball is released. Find the maximum height that the ball reaches in the time it gets there. Okay, so what's the initial velocity? That's 64. What's the initial height? That's 5. So now we got our equation here, our function. See if you can now pause the video here and figure out what the maximum height is going to be for this problem using this function. So try that one out and see what you get. All right, let's see what you had here. If you plugged in all the numbers into our formula here of time equals negative b over 2a, you should have gotten 2 seconds. Now if you plug that back into the function, that'll tell you the maximum height. So anywhere there's a t, put 2. And if you do that correctly and simplify that or use your calculator to solve that out, you should have gotten that the ball reaches 69 feet. So that would be the maximum height after 2 seconds. All right, try some of the practice ones.